Hi everyone, thanks for coming to our second 3D workshop weekend walkthrough. We're having Gray give us a Rhino walkthrough here. We're going to hand it off to him in a sec. I just want to say thank you to everyone who's watching these events, and we're really enjoying having you guys here, really appreciating it. Remember to follow us on Instagram, let us know how we're doing, and ask us any questions you might have. So Gray, please take it away.
Cool. So this is Rhino. Rhino is a NURBS, N-U-R-B-S based surface modeler that stands for non-uniform rational B-splines, which are, you might remember them as the pen tool on Illustrator, which is the control point curve. So basically everything you do in Rhino is based on points and control points. Yeah, let's get into it. So your window here is, when you open it up, you're going to have four windows, which are four different viewports. You can go into one viewport just by double clicking on the name of the viewport. So you got your top, front, right, and then the perspective. You can change that to isometric or whatever you like. I tend to work in perspective because I don't know why, but this program I work in perspective. Most of them I don't. I just find it a little bit easier. Over here, you have your command bar. You can enter the command bar just by typing anything, and it just automatically goes in there. Rhino is a command-based architecture. However, they've made it a little bit easier in recent versions to do it without commands, although it does slow you down significantly. And if you do learn the commands, and you will just learn them just by typing, you can go really, really, really fast compared to other 3D programs because you're not clicking and doing all kinds of stuff. So basically, all the commands are pretty much based on English. They're not, it's not anything crazy. To make a rectangle, you just type rectangle. And you really don't even have to type in the full word. You just type in the beginning of the word, and it'll come up. Rhino learns what you like to do, and it pays attention to what you tend to do. So if you use the circle tool a lot, if you just type CI, it'll come up. But maybe the first couple times, you're probably gonna have to type out a lot of the word just to get it to come up. So you can also do not everything, but pretty close to everything just with these buttons. You click and hold on them, they drop down and it gives you a bunch of options. I sometimes do use these for some of the longer commands that I don't like typing in, because some of them get pretty long. But the most common ones you'll just end up typing. I believe you can use it pretty much, even if you don't have a mouse, you can use this program, which is kind of interesting. It's not terribly easy, but you end up not using your mouse a whole lot, which some people like, some people don't like. I don't know if any of you are familiar with AutoCAD. A lot of the commands are based on AutoCAD commands, which are like the oldest, that is pretty much the oldest CAD software there is. So let's get into a little bit of stuff here. So typically if you're doing a sketch, just like, it operates similarly to SolidWorks in that you sort of make a sketch and then you do something to that sketch. But we'll get into a little bit of differences here. There is no sort of sketch mode versus solid mode. It's pretty much all just in the same thing. So for example, let's say I want to make a rectangle. All I have to do is type RE because I've done it a lot. There are a lot of RE commands, and you notice it's like the 10th one here. But since I do it a lot, it comes up automatically. Now, whenever you enter a command, it's going to give you a little pop-up over here. And that is basically asking you what you want it to do first. So it's asking for the first corner of that rectangle. Now, everything is coordinate plane based. So let's say I want it at the origin, which is the intersection of this axis and this axis here. That coordinate would be 0, 0, 0, but Rhino makes it a little bit easier for you because 0, 0, 0, you could just type 0, and it'll automatically sync to the origin. So you notice when I did that, I'm just going to undo here. It gives you a couple of options as well. You can do like a 3-point rectangle where you specify 3 different points. So if you wanted to do it on a different axis than the X or Y or the Z, you can do it in different axes that way. You can do vertical, which constrains it into the z-axis, center, which picks the center, and then the outside point, rounded, which will round the corners. Don't really use that one a lot. So let's just do a normal rectangle. Also, if you exit a command, by hitting escape and just hit it like 3 times and you'll get out of pretty much any command. And if something's not working, it's probably because you're in a command. So we're gonna type 0, and then it's gonna ask you for the other corner. Now this is the X coordinate. So I'm gonna type 5 for 5 inches, and it's gonna constrain it to 5 inches. Each one of these little rectangles is an inch. And then I believe there are 12, yeah, so each one of these big ones is a foot. You can change to millimeters. We can get into that a little bit later, but most of you work in inches anyway. So let's do 5 by 5. Actually, let's do 5 by 3. So we've made a rectangle. Now you can do a circle the same way. Just type SCI. And you can also just place it anywhere you want and make it for a little bit less accuracy. But a lot of the times you're doing prototyping in this. So it's more of it's very easy to do visually accurate things than SolidWorks is. So, you know, moving things around sort of unconstrained, things like that. If you want more precision, SolidWorks or something like that is probably more for you. You know, if you're building like your final model for production or something like that. But this is a very easy way to come up with a lot of iterations and change things. All right, so let's just do this rectangle here. And we're gonna double click on this top button to bring us back out to our fore view and then into our perspective by double clicking perspective. I'm gonna extrude this. So all you do is you click on it, but if you've already made it, it will highlight yellow. So the best bet is not to click anything between commands because usually what you want is already highlighted. And we're gonna type extrude. Since I've done this a lot, it automatically fills extrude curve. So curve is always abbreviated as CRV. A curve is anything that is a line. It's made up of lines that has no surface to it. In this case, this is a curve, so I'm gonna hit enter. And, oh, so it's extruding both sides. If you look over to your little menu, again, when you type a command, a menu comes up. I'm gonna uncheck both sides. If you look, it's probably really small, but there's a little underline under the B here. There's also an underline under this S. Those are the key letters for each command within this command. So if I want to do uncheck both sides, I hit B and then enter, and now it's just one side again. But what it's really asking me for is the distance. So I can type, I don't know, let's say 4 inches, and then hit enter, and it extrudes it 4 inches up. If you want to go down, type -4. Or the other way, alternatively, you can just direct your mouse towards the bottom and type 4, and it'll do it as well. So you'll see that our curve is still highlighted, and it's still there. You can uncheck a option in here that will delete the input curve. I tend to leave it so it remains there. And then at the end, it's very easy to select all the curves and get rid of them. But I tend to leave them just for reference if I want to do it again. So we've made our rectangle. Now, let's say we want to modify this rectangle. And a lot of the stuff in Rhino that you're going to be doing is sort of building off of a very simple shape. So you make a rectangle, you make a circle, or you make a more complex shape using a polyline or something like that. And we can get into that in a minute. But generally, you're going to be modifying a shape or multiple shapes. Now, you might say, okay, well, let's cut a hole in this rectangle. How do we do that? The easiest way is by, oh, and we're going to talk about O-snaps here, so let's get into that. So you have these things called object snaps, and these are very similar to what you'd find in SolidWorks or something like that, where it snaps to corners and things like that of other objects so that you can constrain things. Now, there are no real constraints in Rhino. You can't like constrain things a certain distance. They're just sort of wherever you left them last time. So that is a little bit of a downside, but it tends not to be a huge issue when you're doing sort of prototyping and 3D printing and stuff like that. So at any time, if you're using Rhino and these little white things don't show up, when you get towards the edge, you see it saying all kinds of things when I go over this line. You're just gonna, whatever command or anything you have up, just type osnap, and that is your object snaps. I believe you can also type object snap, but osnap works. Osnap. A lot of the time in the newer versions, they're just putting it down here as well. And this is the osnap menu. And if this doesn't show up, I believe you can turn it on in your window menu. I just leave it on over here because I like to turn things on and off. And the first thing you want to check is Smart Track. That's these little white dots. This is a recent addition, I think 2 versions ago, where you can basically set different little white snap points that will reference when it's trying to calculate where you want this thing. So to get an OSNAP to work, I usually have end. Near is very useful. Near is, here, I'll check it. Near just basically puts it on any point on a line that it is near, your cursor is near. It can get dangerous because you can be trying to draw something and it'll like lock to a line down here or somewhere inside. So that can get kind of iffy. I tend to leave it on, but just beware that it can mess you up. More useful ones, midpoint, that's just midpoint of any line or object. Center is whenever you hover over, it probably won't do it on this rectangle, but if you're using a circle, it'll just snap to the center. Intersection, that's intersection of any 2 points, or any 2 lines. Tangent is tangent to a circle. That gets more when you're doing like more complex drawings. Quadrants are for circles, that's any extremity along an axis. So whatever the farthest point of the circle from the center on the, well, every point's the farthest point of the circle, but any farthest point closest to a axis. So we can get into that a little bit more. Vertex is for mesh models, which we're not going to really talk about today. And then all these other ones are sort of more for mesh. I'm going to leave vertex off. So basically, I'm going to draw a circle in the middle. Now, the way I do that is I'm just going to exit this because I have all these snaps here. Now, to repeat a command again, you just hit enter, whatever the last command you typed was, even if you escaped it. And I'm going to hover over the middle of this line. And if I hover over it, you can see that white dot showed up. To make that dot go away, I hover over it again. That white dot is now a reference point, and it will create lines based on that reference point. So then let's say I want to be in the middle of this line and the middle of this line, and I want to find the point between those 2 lines. There you go. You highlight the middle, and you get the middle. So now that is the middle of my circle. Otherwise, if you just try to draw a circle on top of this, what will happen is it will revert to the ground plane. So whatever you draw in perspective, you typically don't want to draw in perspective, but I do it a lot. It will revert to this ground plane over here. So it may look like it's right in the middle, and then you'll draw it and it'll disappear. And you're like, where is it? Oh, it's behind and to the left of this object because it looked visually right, but it's actually on the ground plane underneath. So you just got to be wary of that. So I'm going to draw this circle. I can type a radius. Let's say I want a radius of 4. Oops, too big. So again, I just hit escape. Redo this, radius of 1. Cool. So I've got another curve here. I can extrude this curve using extrude CRV. And I want to cut through this object. So I'm going to make this, and there is no way to cut through, there is no cut extrude. And that is on purpose, because that is not the best way of doing it. in this kind of modeler. The best way of doing it is with Boolean operators. So we're going to make this, and we're just going to cut through a little bit extra just to make sure it goes through. And you notice that when I when I finish that command, the circle's still highlighted, so I can just hit delete. And there we go. So what we're going to talk about now is Boolean operators. And these are the most powerful tools you have, pretty much. Think of these as the Pathfinder tool. I'm assuming some of you are familiar with the Pathfinder tool in Illustrator. This is exactly the same thing. You have 4 options. You can, so again, they're just, you type the word Boolean. The first couple times you will have to type the word Boolean. Boolean is spelled B-O-O-L-E-A-N. And then it'll come up. There is another one, we're not going to talk about that right now. So basically what you have is union, split, intersection, and difference. So union is like union. I think it's called union in Pathfinder on Illustrator. And that all that does is it takes the 2 objects, I'm going to do it right here, and unifies them into one object. So I hit that, they're now one solid object. There's no, the circle in the cylinder inside is gone. And all that you have left is the bottom. And then on the top here, it looks like it's still there, but all that is just a it's a boundary line that doesn't really exist. It's just basically a history of what you've done. I'm going to undo that. Another option we have is Boolean difference. And that's what we're going to use here. And difference is you take one object and subtract the other object. So I'm going to hit it, and it's going to ask me over here, select surfaces or polysurfaces to subtract from. I want to subtract from this rectangle. I'm going to click this rectangle and hit enter. Now, select surfaces or polysurfaces, subtract with. So this is your cutting tool, whatever you want to cut with. This is, in this case, the cylinder. We hit that and then hit enter. Over here, you can check delete input. That deletes this cylinder, whatever the cutting object was, and just gets rid of it. Typically, I leave that on, but if you want to preserve that cutting object, you can check that off. So I'm going to hit D, and then I'm going to hit enter. And there we go. We've cut a hole through it. Now, Booleans are permanent. There is no going back unless you undo. So it typically, you want it to be the last, if you're going to modify anything in any way before you cut, you know, it's like real life. Once you cut something, it's cut. We can get into the end about how to fix things like this, because there are ways to sort of patch this back together, but it is permanent. So just keep that in mind, just like the Pathfinder. So we're going to undo that, and we're going to talk about the other 2 things right now. Another option you have is Boolean split. That would also work in this case. Boolean split is like subtraction with keeping all of the inputs. So let's say I want to Boolean split this. I'm going to type Boolean split, or just hit enter because I just did it. I'm going to select my, there we go. So I'm going to select the surface I want to split, which is this rectangle. I'm going to hit enter, and now I'm going to select the cutting surface, which is the cylinder. Hit enter, and now nothing has changed, right? Almost. So what it's done is it's left the cylinder, which I can delete. But what it's also done is it's cut through this and cut out the piece that would have disappeared with the last command, but it has left it behind. So now I can take this and I can move it out of the way, or I can do something else with it. So that's basically, it is finding the intersection of those 2 objects and leaving behind the result. So so an option here would just be to delete that. Here's something else. When you do Boolean split, it leaves behind a copy of the original object. You can turn that off. I leave it on. And what I typically do is just drag it out of the way so I have a copy of it that I haven't edited yet, just in case you want to work backwards. So there you go. The other one is Boolean intersection. That's very similar. It basically just creates your first object, your second object, and then an object that is the combination of those 2 objects wherever they overlap. And I don't use that one a whole lot. It is useful. but pretty much everything can be done with the first three. All right, so let's see here. Oh, that is, there we go. Okay. So let's say, yes, we want to cut a hole in this object. So we're going to Boolean difference, select our cutting object, and we're done. So we've got this. Now, let's talk a little bit about surfaces. So this is a closed poly surface. It has no holes in it. There is, you might say, oh, there's a hole in it, but there is still a wall on the inside, so it's a closed surface. This object can be exploded into its component surfaces. And each of, now that I just typed explode, each of the, oh, what happened? I guess it didn't explode. There we go. Yeah, so now I have all these little surfaces. And these can be moved and adjusted and whatever. But it's not a closed surface. This is not something that you can print. These may look like walls, but they have no thickness. They're just surfaces. This is an advantage and a can be an issue because you can create objects that are not possible to be manufactured because they're made up of surfaces that are not solid. So if you tried to 3D print it, it would just spit back at you nothing, or it would try to estimate what it was. Once a surface has been exploded, or explode, then it can be rejoined just by typing join. That's the same command as it is in Illustrator. And we can get into that a little bit more. Next thing we're going to talk about is compound shapes. So you can make any number of compound shapes for extruding or revolving, or we can get into that. One of those ways to do that is with polylines, which is this button here. You can also just type pline, or you can type polyline. Again, it's just shorthand. Pline is pretty easy to remember, and if you do it a lot, it's just PL, and then it comes up. So let's say we want to start it here. You know, you can make any sort of compound shape with right angles, or with just angular angles, and close it. Another option you have is if you want to make curved lines, you type, what's it called? I always forget this, handle curve. So handle curve, or you can go over here and click on the sort of curve thing. And there's a bunch of options for how to do, like, different ways of drawing a curve. I usually use handle curve. That's similar to Illustrator, and it will look familiar. So I enter that, and you can press and hold and drag, and you get a curve here, and that gives you your curvature curve, and then you have a control point. So the next control point will be here, and then I click and drag, and it does this. You know, that should look familiar to a lot of you, and you can do that all you want. Now you notice the handles go away, and they're not visible. Once you finish, you can actually edit these, and if you just type points on, and that'll show you all of your control points. They look a little bit different than they do in Illustrator. They actually don't. This is what Illustrator is doing behind the scenes that you're not seeing. But it's basically taking these different points of influence and trying to draw a best fit line between them. So you can see here is your, basically it's the same thing as Illustrator. So you have these control lines here with the different control points. You can move these and influence the shape. You can move your actual control points and influence the shape. And all it's doing is just connecting those control points with another line. And then you can turn that off just by typing points off. Oop. I'm in a command. There we go. It turned off. All right. Another thing is this thing right here, this green thing, this red, green, and blue thing. This is called the gumball. You can turn it on or off just by typing gumball. And it off. Um, this is basically your friend for moving things around. You can click and drag on any of these. It'll move them in a specific axis, whichever way they're pointing at. You can scale things by clicking or dragging on these rectangles. You can scale uniformly by holding shift and dragging on one of these squares. And you can do this precisely just by clicking on any of these boxes. And if you click on one of the little boxes, you can scale by a factor. That's your number. You can scale by 1.2, something like that. You can also do these with with these little moving arrows. You can move it 5 to the right, which it does, or -5 to the left. And that's very useful for just for moving things around precisely or imprecisely, depending on what you're doing. So this is a curve. Your other option is a surface. And the easiest way to make a surface is surface by point. A surface is always abbreviated as SRF. So any command that is a surface command is SRF and then something, except for extrude, which is backwards, so it's extrude SRF. That's just because that's the way that AutoCAD did it, that's the way they did it. So SRF PT makes a surface by point. Points are, yes?
Okay, I just had a quick question. For the curve, if you wanted where it connects together, if you wanted it to be like tangent, how would you do that?
Oh, like to make this nice and smooth?
Yeah.
That was just the way I drew it. I kind of drew it poorly there. When you're drawing, if you grab the same point that you started on and just drag in whatever direction you were dragging, it'll line up nicely. Another way is you can actually just fillet this and flatten it out.
Okay.
Typically, you don't want to do filleting. It's the same in SolidWorks. You don't want to do filleting in a sketch because then it gets kind of complicated to modify it.
Mm-hmm.
But yeah, when you draw it, oh, you know what? I'm going to do this one more time because I forgot something here. This is important. Fair enough. So when you begin your drawing, you typically want to start on an axis. So the way you do that is when you start your drawing here and you start your control point, anytime you're doing anything, if you want to go in one of the axes orthogonally, then you hold shift and it locks to any of the axes. So I typically, if I'm starting like a complicated curve or something like that, I'll start on an axis. That way I remember that I started on that axis and I can just meet right back up with that axis. And then you can rotate it if you don't want to actually keep it in that orientation. So yeah, you can start it on an axis. You can also do that. If you hold shift while you're actually moving, it'll constrain it to the same axis that you started on. I kind of didn't want to do that. So I click and then hold shift and then it'll do it. And you can come around and finish up your organic shape here. So there you go. Now it meets up nicely and it's tangent. So that holding shift works for pretty much anything. It'll constrain it to one of the axes relative to whatever you just did. Right, what was it doing? Oh yeah, so with sketching, you can also trim just like you would in any other program. Let's say I wanted to combine these two things. I highlight them and I just type trim. You highlight everything that you want to trim and everything you want to trim relative to. So if I just highlighted this one circle and I tried to trim the inside, it would just delete the whole circle because there's no intersection going on. So now I can just go around and click on all these inside things. So when I'm gone, I can alternatively click and drag a box and it'll go away, anything that touches that box. The boxes have the same, your selection boxes have the same rule that they do in any other 3D program, where if you drag from the left, anything that touches the box will get deleted or will get selected. And if you drag from the right, anything will get selected that touches. If you drag from the left, anything that is contained within the box gets selected. And that's pretty much across the board, all CAD programs. So I've trimmed that object. I hit enter. And if I go to actually like try to do something with this, it's in its little component parts. So after you trim, it's pretty much a safe bet just to type join or just J. There aren't that many J commands. It'll probably just come up. And now it's one surface, or sorry, one curve. Another thing you can look at is this history right here. This will sort of give you a little insight into what it's doing. You can see that when I joined here, if you can read that, I don't know if you guys can read that. It said 4 curves joined into one closed curve, which is good because that means I can now extrude it. Now, just because something is closed doesn't mean, or sorry, just because something's open doesn't mean you can't extrude it or use it. Rhino's a little bit different here, and this might seem kind of weird, but you can actually extrude open curves. You can extrude anything you want. All it does is it will extrude it into a surface, not into like a body. So you could take, one of your components here, and you could extrude this into a surface. That can be useful for a number of applications for cutting and shaping things, because then you can use this as a surface along which you can split something. So if I wanted to take this, and I can modify this sort of the angle of this with the gumballs. Yes, so if you drag on these little curves here, I don't know if I mentioned this, you can rotate the object on its center of mass. So I'm going to move this over here, and I'm going to use this to cut this block over here. So now I can use this as a cutting object on this block using our Boolean commands that we learned. So we want a Boolean split, or Boolean split. Boolean union and Boolean difference won't work in this case because you're trying to merge a surface and a poly surface, which don't merge. But splits will work. So we can select our surface we want to cut and the surface that's doing the cutting. And we can delete this surface. And now we've cut the top of this. Again, it leaves a copy of its original body. And you can just drag that away or delete it, whatever you want to do. And there you go. You've just cut that. So that's the way you make more complex things, is sort of by making a very basic thing and then sort of cutting away at it and adding things to it and stuff like that. So let's talk a little bit about, does anybody have any questions? Also, I just want to ask anything at all? No. All right, cool. Let's talk a little bit about, oh yeah, so when you extrude, you can also add draft angle if you're looking to do that. It's just a box that's checked down. Let's talk about like, you guys, let's see. All right. Let's do some like revolves and stuff like that. And we can do, so let's do a little rectangle here. Again, I can go over here, just click rectangle. This here, you can drop down different kinds of rectangles. Let's do a center to corner point. If you hold shift, it will constrain it to a square, just like Illustrator. I think if you hold, no, maybe not, never mind. There you go. Let's make the square. And let's say we want to round the ends on this. So we can make a circle, like CI comes up. Again, we can snap to the midpoint, and then we can snap to that end. Now, let's say we want to bring this to the bottom as well. Well, what we can do is we can click on the circle and type copy. This is not like copying in the way that you can then paste. This is the copy command. There's also literally you can just type Command C, Command V, and it'll just copy whatever you clicked and paste it exactly in the same spot. But this is the copy command, so this is a little bit different. You click on the point that you want to copy it from In this case, I want to copy it from here because that point also exists on the bottom. If I copied from like this vertex here, I can't really lock to this. And the same with the top one. But because this point also exists on the bottom, I would like to copy from there. And I'm just going to move it to there. And you can keep doing this many times as you want. Once you're done, hit enter. And you're good. Now I want to get rid of this middle stuff. I highlight it. And I type trim. Trim. And I select everything inside here. Goes away, miss some things. And then I hit enter and then type join. And that's one thing. I'm going to move it up here a little bit. Now, let's say I want to revolve 4 of these things. How do I do that? Well, let's say it's a complex thing and you don't want to copy and move it if you want it precisely. So we can do an array, just like in any other software. So arrays are called other things sometimes, but in this case, they're called arrays. You can do a linear array, which is just array. You can also do a circular array, which in this case is called a polar array. But the command is array polar. And that will do around a circle or other circular shapes. But I want to do a linear array. So let's do just array. And it's going to ask me how many I want in the x direction. So if you can't remember where x is, it's always along this red line, unless you've changed something weird. Y is along the green line and z is up and down. So I want 4 in the x direction. And then it asks me how many do I want in the y direction. So that is additionally, you can also then array it 4 across and then another 4 on top, or like however many you want. Let's say let's just do 1 for now. And then how many do I want in the z? You can also array things x, y, and z at the same time. So you can make like a whole grid if you want. So let's just do 1. And it's going to ask me for the first reference point. I usually just click on, this is where it's scaling your array from. I usually just click on one of the extremities or the center, depending on what you're doing. And then once you click, you'll see that a couple of other things show up. Now I can just freehand this just by clicking, or I can type a specific distance. Let's say, I don't actually know how big this is. So let's just click for the safety of this. Once you type your distance, it does not lock that in yet. So let's just do 4. And it says, are you sure basically you want to do that? And you can then change, oh, hang on. Yeah. Oh, nope, didn't work. Sometimes it doesn't go the first time. We got 1. All right, so I'm just going to freehand this. You can go through and type it. There you go. So then it asks you, are you sure that's your spacing? You can then change your spacing to like 12 or 10 or whatever. Let's just do 12. And you can also then change the number. So you could do like 5, and it'll add another one, whatever. Let's do 4. And again, you just sort of follow this menu. It pretty much explains everything you need to do a command. Let's hit enter again. And there we go. Now we have 4 of them. So let's say we want to revolve these around a line here. So we need to make a line. You don't have to make a line, but if you want it to be somewhat precise, you should. Let's say we got that line. Let's take all these. Right. And we're going to type revolve. Pretty easy. It's going to ask you where you want your axis of revolution to be. So we want it along this. So we're going to click the start, which is here, your end, which is any other point on this line. And then it's going to ask you up here what you want your start angle. Now, start angle is wherever you want it to start. So say you wanted it, you drew it down here, but you wanted it to be from here to here or something like that. You'd type in 90 if you want it to be vertical to horizontal or whatever. Usually it's 0, so you just hit enter again and it starts at 0. And then visually it'll show you what it's doing. And in this case, we want to go all the way around, so it's already typed in 360. This angle will be whatever you did last time in this specific file. So last time you did 270, it'll be 270 again. All you have to do is type 360 if you want it back. You can go more than 360, but there's no real reason to do that. So let's do 360, and there we go. Again, it leaves your sketches highlighted. You can either delete those or move them or do whatever, or just leave them there. And also it leaves the axis. And there you go. That's how you revolve. Rhino does not have a cap on how many bodies you can have in one model. You can have as many as you want, and they do not have to be connected, which is nice for sort of prototyping things. And you could, you could take this whole thing and copy paste and just move it over here. And then if you want to shrink it, let's say you want this one a little bit smaller, do it over here, something like that. So you can just leave whatever you want. It's kind of like a big workspace, I treat it that way. Some people don't like it when you treat it that way. The file sizes are extremely small, so it's not going to really slow down anything unless you have really complicated things, which most people aren't going to really run into. Let's get rid of this. Let's talk about lofting. You can loft, you can sweep, you can do any of that. Let's say we like this curve. Yeah, let's make something new here. Start with a rectangle. Do that, and then let's add. You can also do, different polygons. The command for that is polygon, not to be confused with polyline. Let's say we want to make a three-side triangle. And let's put it over here. Share line. It'll ask you. You can just do it wherever you want. And then we want it on the other side. Well, you can mirror. You can mirror anything. You can mirror a 3D object. You can mirror a 2D object. You can mirror a line. It's going to ask you where you want your mirror plane. I'm going to mirror it across the center. So I'm going to go over here. Wait till a little white dot shows up. Click. And then you can see I can also just put it wherever, but I want it to be constrained to the center. So I click the other midpoint. And there you go. Now let's trim. Get rid of all this inside stuff. And hit enter. We join. There you go. So to loft, you need you need two or more curves that are not in the same plane with each other. There are ways to make planes, but you don't need to make planes. Your best bet is to just use the gumball here to move things around. So let's say we want the same profile up a bit and we want it a little bit bigger in the X direction. So we can copy, Command C or Control C, paste, Command C, or Control V. Sorry, you know what I mean, yes. Same command, and then we can take it and we can drag our copied shape upwards. You can also do this precisely by clicking and typing. Let's do 10. There you go. Now let's say we want this to be a little bit wider. We're just going to scale it this way. And then we're going to copy and paste it again. And we're going to drag it up another 10. And I want this one to be there and a little bit longer, whatever. Cool. So we're going to highlight all of our curves that we want to be in the loft. I think there's no limit on how many you can have. It will get a little weird, though, if you have a lot of them, especially if they're not the same number of sides. But it will do sort of more complex things as well. So I'm going to highlight those three, type loft, and hit enter. It's going to ask me where I want my seam point. That is the point where the two sides join. In this case, they should all be this. If they're all the same shape but just different sizes, then you just want them all in the same place. If it's a complex shape, you just want them to be somewhat in line with each other. So that'll work for this. You're going to hit enter, and it'll pop up this little window. You've got a bunch of options for how you want it to develop the loft. You can do normal, which is through all of the facets of your original shape. Loose will match the first and the last one, and will guess where you want the other ones. Basically, it'll sort of round everything out. Tight, which is constrained to every single profile. Straight sections, which is just literally straight lines between different profiles. The other two, developable always looks weird. I don't know what that's for. And then uniform typically does the same thing as normal, but just in a different way. So usually it's either the normal, loose, or tight. Let's do normal. If you check close loft, it will try to complete this shape into a torus. I don't know why you'd need that, but you can. It makes it look really weird. Doesn't really work that well. Normally you don't do those things. So there's your loft. I'm gonna hit delete. It'll delete all my curves. Oh no, it's just made up of planes. It's not a solid shape. What do we do? Well, we click on it and we type cap. Cap will create caps. It will just cap this object off and turn it into a closed object. And there you go. Now, if cap doesn't work, there are a couple of ways to get around that. I'm not going to get into that right now because that's like a 20-minute long discussion on different ways. But you can just Google that. And it's not terribly hard, but usually cap will work. So that's lofting. Sweeping is much the same as it is in any other program. You draw a line and you sweep your curve along the line. And then, yeah. Does anybody have any questions?
What is it?
What's what?
What you just made? What is that?
I have no idea.
Ah,
Just a nice complex shape.
yes. Sorry, I missed the first part of this.
Oh, it's all good. Yes, Tom, you had a question?
Yeah. So one thing I've heard from my classmates who have used Rhino, they said that it's a lot easier to do like 3D like surface modeling.
Mm-hmm.
So for one of our projects was we had to choose something, and one of my classmates modeled an Xbox controller.
Yep.
Very ergonomic, flowy shape.
Mm-hmm.
I was wondering if you'd show us like kind of how you would start doing something like that, and why it's better than like Fusion 360 or something.
A lot of people say that. I don't fully believe it. I think that there are Fusion is very good at doing organic shapes and things like that. And there are a lot of other options. The best way to do stuff like that is to create your sort of profile, either sweep or loft a profile, and then start cutting away at it with different sections, and then sort of rounding it out that way. Like I did over here, you can sort of do this all over and really get sort of like complex intersecting curves, but you're still sort of constrained like you would be on a bandsaw, where you have your sort of X, Y, and Z cut. And then you can do more complicated things like you can sweep a bunch of open curves into a very complex surface. And I can demonstrate that real quick if you don't understand what that means. So I could take something like a handle curve here and make, I don't know, some weird shape. And then I can then take this and I can do all kinds of, I can revolve this shape around something into a surface that is going to be a big curved surface. I can then loft this shape. I can make something really complicated like this. Well, here, let me draw another one in there just to demonstrate. Yeah, so I can make something that can be used as a cutting tool that is very complex, and then use that to cut away at a block or something like that and create a very complex profile pretty easily using that split and Boolean split and things like that. Again, everything sort of comes down to Boolean operators, your Boolean split, your Boolean union, and your Boolean difference.
Yeah, if I could just jump in there.
Yes.
A lot of times people talk about one software being easier than another. it's true, but only for certain applications or certain shapes or certain instances. So I'd say I was using Rhino before I got into SolidWorks, and when I went to SolidWorks, I sort of missed the sort of sketch quality of it. You just sort of think it and make it and move
Yeah.
on, and you can stretch it and pull it and move it, stuff like that. But once I got into SolidWorks, was working on a project and I tried to go back to Rhino, and it was impossible because all the tools you get in SolidWorks, then I was missing in.
Right. Yeah. So I use this program mostly for prototyping and for just quick sort of thoughts. I use it for, I have this idea and I sort of want to do like 20 iterations on the same document without moving anything around, or just do them all at once. And you can sort of play with things. But if you're trying to make something really specific and you want to be able to sort of change really minute things about it, then SolidWorks is the way to go, or Fusion is the way to go. But it is a deceptively powerful tool. It doesn't look it. It looks very dated. I don't know why they haven't changed it. I am actually thankful they haven't changed it because it stays the same. They just add features, but they don't change any of the core functionality, which is good, I think. It's also $100 for the whole software if you're a student, and that is a full license forever, no upgrades. And then each upgrade, I think, is only like $50. They don't change a whole lot between versions, and versions don't come very frequently. I think we're on Rhino 6 now. I have Rhino 5, which has pretty much all the same stuff. I think they added a few things here or there with the rendering panel. You can also render stuff, and that's a whole nother topic we can talk about, the material editor and rendering and stuff like that. But it is, for a student, this is pretty much the cheapest software you can get. That is, other than like the free ones, this I think is probably the most affordable, sort of more advanced surface modeler. All the computers in Booth have it, including Macs. It is Mac and PC friendly, no anything.
That's a big plus.
Yes. And files are directly transferable, so it doesn't matter if you make it on a Mac PC.
Yeah.
However, there is no backwards compatibility, so you can't make something in 6 and open it in 5. But you can make something in 5 and open it in 6.
Yeah, there are companies, and depending on where you're working, that this is their primary application. I know of one kayak company. This is what they make their kayaks with.
Yeah, so I've had 3 internships, and 2 of them were Rhino based.
Really? What products were they making? Do you
So
know?
one of them was a scenic designer. They make sets for amusement parks, and they were pretty much only Rhino, just because Rhino is very versatile in file type. You can open pretty much any other file type in Rhino, and it'll work most of the time, and then you can save out as anything else. So you can go between AutoCAD and other things that you wouldn't normally be able to go through.
Yeah. So the good news is with Rhino is they're not upgrading it every year. The bad news is they're not upgrading every year. But the good news is they're not upgrading it every year.
Yes.
The good news about SolidWorks and Fusion is they're updating it every year. The bad news is they're updating it every year. So when I'm trying to teach it next year, it's like I've got a new piece of software. They're bells and whistles. They took away something that I always used and they put something in there. And I don't realize it's there until some student does something. It's like, oh, that's pretty cool.
Mm. Yeah, it's definitely, it looks very basic, but it has a lot of features. But they do a good job of following that 90-10 rule where, they only give you what you're probably going to use. And if you need to do something, you just Google it and it's a command and you just put it in and you're done.
Well, now Fusion and SolidWorks have the 90-10 rule, but they reverse it. You only use 10% of the software at any point in time.
Yes.
But you pay for all the software.
Exactly. There are like plugins and things like that that I don't do a whole lot of, but there is a very large community of online people that there's a whole forum and everything like that, and they're very, very helpful if you ever need it. I got to run here. I have work here, but thank you all for coming. And if you have any questions, you can email me. I will post my email in the box here, or reach out other ways. Hope everybody enjoyed.
Yeah,
Yes.
thank you so much, Gray.
Thank you.
Really appreciate having you. Yeah, if you guys, you can email him, or if you ever want, we can put you in contact if you get in touch through Instagram to IDSARIT. That's also possible. Thank you so much. Really appreciate it. Really appreciate those who are able to stop in, check out Rhino. It's really nice to be able to see a variety of different modeling softwares. That way you get, better idea of how, how you can approach a problem. So thank you so much. I will let you go because we know you have to get off.
Thank you, guys.
Yeah.
Thank you.
Thank you.